Hello, my name is Charles Allison, and in this presentation, I will be showing you why phosphate is able to expand its octets. I'd like to start off showing phosphite and nitrite. Both phosphite and nitrite have a standard Lewis structure. Upon oxidation, they both get one more oxygen. Now, the difference here is that phosphite has a -3 charge, whereas nitrite has a -1 charge. But that's the only key difference between them. Now, some of you may already see a key difference between phosphate and nitrate. Like their predecessors, phosphate has a -3 charge. Nitrate has a -1 charge. The key difference is what happens when they have a double bond. Phosphates is here, nitrates is here. However, the nitrogen in nitrate has a +1 charge. But where's the charge to the phosphorus? Well, it technically has no charge, and this is because of the unique ability phosphorus has. Now, when I say unique, I don't mean just a phosphorus. Other elements in the third period, specifically nonmetals, are also capable of this ability. Here I have drawn phosphate with single bonds. As you can see, phosphorus now has a +1 charge, and the oxygen that had nothing now has a -1 charge. Phosphate's secret ability comes from the fact that phosphorus is capable of tapping into 3d orbitals, an ability shared with other elements in the third period, like sulfur and chlorine. Because of this, phosphate can form a double bond with one of the oxygens. Here's that bond. Phosphorus has no charge now, and oxygen also has no charge. Thus, the phosphate is able to expand. A better way to explain this is with this. This is a polyphosphate. Polyphosphates are able to repeatedly go over and over and over. This is what these tildes mean. That squiggly line right there means that this pattern will continue to repeat itself. This is because the phosphorus and the oxygen now have a null charge. They do not have a positive or negative charge to repel each other, and thus can continue forever. Now, some of you can probably see a problem right here. It's this little guy. That +1 charge makes this an unfavorable formulation. We'll go ahead and call this a polynitrate. Now, unfortunately, nitrogen, being a second period element, has no access to a d orbital. Due to this, nitrogen is unable to expand its octets, and thus, if you were to try to form this, it would likely tear itself apart, because, as you likely know, like charges repel like charges. They don't want to be together, and having no charge between them just makes it all that much easier for them to split apart. With this knowledge in mind, you can hopefully now see why phosphate can expand its octets. Thanks to phosphorus's unique ability to tap into 3d orbitals, phosphate is able to expand octets upwards of 10 and create polyphosphates which repeat indefinitely. I have been Charles Allison. Thank you for listening to this presentation.